Great, great. Hi Laksh, hi Ravikant, hi Tushar, hi Lloyd, hi Sandeep, hi Sharvana, hello Sanjay, hi Tushar. Hey, thank you Tushar, thank you for wishing the Teachers Day. Yeah, all right. Hi Himanshu, thank you Tushar for the wishes. And yeah, hi Suresh. All right, all right. So, did you get a chance to look around at Hey Jairam, Hey Vidya? Great, great. Did you get a chance to look around the cloud labs and browse Ambari or Hue or have a look at Veti? Great. All right. So a quick question to all. If you have looked around, let me go to this place. So at how many places can we create a folder? So basic question is that how many file systems are there? Anyone? Right now, we have four hosts: Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4. And and um, how many do you think have the? How many do you think have? What do you say? So how many total file systems are there? Okay. All right. Karthik says Hue is just UI for Cloud Lab. No, Hue is a UI provided. Hue is an open source project which provides an interface to various Hadoop components. All right, it's a general component. It's not specific to no big data. So you are not learning something which is specific to no big data. All right. All right. Good. Good. Sarna says that local are four and one is HDFS. Brilliant, brilliant. So basically, I will just show you quickly what do I mean by. Let me copy the password so that I don't have. So I will show you. One is this hue. Okay, hue basically lets us manipulate the HDFS. All right, I'm explaining it because this is a common confusion. This is a common confusion, and this is a very common classic confusion in a real-time system. Okay, so the thing which we I learned from hosting this Hadoop for all the people is that people are really facing the same doubts that they face in organizations. Okay, if you are running in a virtual machine, you will never get to you will never have a doubt about such things. You will have um, because there is only one node and there is no doubt about anything. So that is why I'm happy that this CloudX Lab is helping candidate really ask the right questions. All right. So if you see here, this is one. Let me just log in from your account, the account for this batch, and let copy paste. All right. So one is this. This is nothing but a HDFS, and we already talked that there is a single name node, and therefore, no matter where you access the file system from, the Folder structure will be the same. Okay, the folder and files will be accessing the same file structure. So you can see there is this one. All right. And second is, if you try to log in through the VETI, through the browser based console. So okay, Hadoop 17, and okay, so this is Hadoop 3. And if you say ls, you will see these folders. Let me try to make my own directory. Okay, I created my own directory here, and I created my directory here, and I can also sort of rename it to my own, I mean, saying web based one. All right, this is very important to clear this confusion. Okay, move this to 3. I'm just renaming my folder from asgiri to asgiri underscore 3. All right, next is I can SSH to Hadoop one. The way I have launched the browser based VETI, on this one, we can also launch, we can connect directly to the Hadoop one. Okay, sorry, let me say Hadoop 17. I will answer your questions in a minute. Hadoop 17. All right, now here you see there are no folders created yet. I can create my own folder here. I'll just name it differently. All right, so now you can see that. So this is on 1. I exited, and now I'm logging on Hadoop 2. I'm logging on Hadoop 2. All right, here also there are no folders created, and I can say sgiri underscore 2. All right, and Hadoop 3 we have already created because we are logged in into Hadoop 3. Now let's log in into Hadoop 4. All right, here also there are no folders with sgiri name. I'll just create my own. See that? Now, if you look at it, so we created a total of 5 folders. Brilliant. Thank you, David. Thank you, Sanjay. And I think everybody got it. So effectively, do not keep your, I mean, when you, most of your programs, when you are launching a program, be it MapReduce or anything, will be in the local file system while your data will be on HDFS. Okay? All right, brilliant. So thank you, Lloyd. I think you got the answer. And yes, good, good. All right, all right. Now, some of the people asked me that what if we create a virtual file system and and use that for launching HDFS? Meaning, data nodes do not have hard disks. Instead, they have virtual remotely mounted disks. Okay, definitely possible, definitely possible. But the problem with such an arrangement is that transfer of the data would still happen. Basically, Hadoop takes care of transferring the code near to the data, but if your data itself is remotely located, then data locality cannot be utilized. All right, so that is not very efficient, but definitely possible. Great. All right, so before we proceed to our usual discussion, do you have any questions for me? All right. All right. There is a question from Sarvana. He says that, for example, data node 1 has data node 1 has block number 2 of file number 1 and block number 1 of file number 2. Okay. When we try to access file number 1, when we try to access file number 1, it goes down. In this case, replication happens only for file 1 block, or it happens for all the data. It happens for all the data. Okay, because it's trying to recover from a failure, which means the moment the moment any of the node is lost, it has to recover it. Okay, so yeah, to defend against the future loss, it has to replicate it. Good, very good question. Any other questions? All right, so I'll say it happens for all the data. Good. Next is that in a Hadoop cluster, do all the data nodes have to be of the same configuration? Okay, so I will answer this question in a little different way. So CPU, no. Storage, no. You can see it clearly if you log in into our Ambari. You can see this. I think that will be a better way to answer your question. So let me copy it again. Hadoop 17. All right. All right. So you can see these hosts. All right. You can see that the first data node has 4 cores and has different memory. Second has different. Third and fourth have same. Okay. So it's not really required. So CPU and storage are not a constraint. CPU, storage, and memory. You can see the storage also here. The disk also is, you can see. Now, what is important right now is OS. With respect to OS, although the core Hadoop does not bother, but the provisioners such as Ambari enforce same operating system. Okay, so effectively, answer is no. So answer is no. And they enforce it, Ambari and say Cloudera installer, they enforce it because it's not a good practice to have different operating systems. Because the tools you will be running will have a different behavior. Also, the architecture of CPU, 64-bit or 32-bit, has to be identical over whole cluster. You cannot have that name node is having 32-bit architecture and data node has. Okay, so either all of them have 32-bit architecture or all of them have 64-bit architecture. Good question. Good question. All right. Sarvna's question is that I will just try to mark it. Okay. So this is all right. Now, next question is, can you explain HDFS storage 80% and 20% of the local file? All right. So if you notice that this file system, which is HDFS, is also made up of the storage from Hadoop 1, Hadoop 3, Hadoop 2, Hadoop 4, right? It has taken piece out of all of them and we have created this file system, right? And therefore, or let me quickly draw it for you. Okay, so let's say there are 1, 2, 3, and 4, right? These are the 4 hosts. Out of this, out of this, we have created sort of a newer file system. This newer file system, we have taken this much out of everywhere. This portion, this portion, and this portion, and this portion. Okay, we have taken this from each of these and build a newer file system. This is HDFS. Okay, these are local file system. So basically HDFS stores its files here only. Okay, or let me try to make it a little bit more sensible, not like this. Okay, how can I rename it? Okay, so HDFS is essentially made out of these things. So how much each node should give away its storage to HDFS? Okay, that's the question. So what each data node does is it keeps 20% for itself and 80% for gives to HDFS. But that does not mean the moment we install data node on one machine, suddenly its disk space is only 20% left. No, it means that HDFS can consume 80% of this disk, 80% of this disk, 80% of this disk, and 80% of this disk. If it has 10 GB, 10 GB, 10 GB, 10 GB, which means the total HDFS size will be 8 plus 8 plus 8 plus 8, 32 GB. And out of 32 GB, if you have a replica factor of 3, approximately you will get 10 GB of total storage. Make sense to you, Sravna? All right. Now, next question from Anandita Raut is that on what basis can you partition name node 1 and name node 2 like it is total memory of the name node? So, okay, so probably you are talking about HDFS Federation, right? Is it Anandita? All right. In those cases, it would depend on how much. It's basically your call. It's basically your call. If your name node is becoming full and you are hitting the upper limit of the total number of files which HDFS can handle, then you might like to divide some of the data into one name node and some into another. Okay, so in those cases you use HDFS federation. And okay, so and and basically it is up to what is your financial budget, as well as how much, to what level do you want to expand to. All right. And the total memory is basically how much ever you can afford, because the more the memory in name node, the better it is. Okay. And you can also observe the total amount of metadata being consumed per file. It consumes around a KB. Okay. Or not KB, as in it consume around how much I should say, that it consumes around at least half a KB. 512 bytes of data is consumed in one file. Okay, so you can do a back of the envelope calculation quickly and come up with a number. Does it make sense to you, Anandita? All right. Sanjay's question is, why does Hadoop works best for large file sizes? Common sense dictates that small file sizes should be processed faster. So, okay. So, when we talk about small file sizes, the only reason why we say that Hadoop HDFS works best for small, big file sizes, because first, first the metadata consumption is very high. Now imagine that, as I told you, that each file, irrespective of how big it is, consumes equal amount of metadata, right? If you have more files, say if you have 1,000 files of 1 KB each, they are consuming 1,000 times of memory at name node than one file, right? So if you have 1,000 files of 1 KB each, and if you have 1 MB file of 1 KB, 1 MB file, single one, then the 1 MB file consumes 1/1,000 less space. Okay, therefore it's always considered better to combine all these files together, like in a zip file or like in a tar file, and put it. We'll talk about a format. We'll talk about a format, and we'll talk about how to compress the files such that they are more suitable for name for HDFS. All right. Second is splitting headache. When splitting is not required. Okay. So let me turn off my chat notifications. Some of the students are pinging me. All right. I hope I answered your question, Sanjay. Moving on. Okay, so there is a question from Vidya. After client gets the data position from the name node, does it read directly, or the does it use the what is comps? It Okay. So if it is available, if it is local on the same machine, then it accesses directly. Okay. If it is over the network on other data nodes, then it accesses directly. It doesn't go through the name node. Okay. All right. Okay, so did that answer your question, Vidya? All right. Now, Sandeep's question is, do we have any data node as a buffer so that they can be used for replication? Do we have any data nodes as buffer so that they can be used for replication? So data nodes are used for replication, right? Data nodes are used as a replication. There's not a special nodes. And the replication happens between the data nodes. Now, next question from Sarvana is, what's the meaning by write once and read multiple times? Okay, so if you try to understand the way HDFS tries to create files is is quite it splits the into blocks and puts it into data nodes. And in case you want to edit a file, it's equivalent of deleting a file and creating a new one. Although there are minor optimizations here and there, such as only those blocks which are being edited will be modified, but mostly mostly when you are trying to delete a file, modify a file, it's equivalent to rewriting the whole file. Therefore, HDFS is great if you are either appending to the file or reading the file or creating a fresh one, not for modifying a file. That is why we call that HDFS is write once and read multiple times. Also, through the multiple data nodes. Okay, so therefore, because it has replication and also, so it's quite faster. While writing, since it goes through name node, it modifies name node. Therefore, it's little expensive process. Tushar's question is there a threshold failure time for a data node after which data node starts replicating? So there is, as soon as it fails, as soon as it notices that it has failed, the heartbeat doesn't respond, then it starts replicating immediately. It doesn't wait for it to come back. Sarvana's question is, there is something called checkpoint process. We have not discussed that yet. Okay, so when we were discussing the load balancing, we will talk about that, although it's not very important. Okay, so the name node, while creating the metadata, as in whenever user is making changes, name node keeps on taking the snapshot and committing it to the local disk. Okay, periodically. And basically it has something called main metadata and something called one thing it is called, there are two parts of it. One is called log, like transaction log in databases. Other is called image is a mirror dump of the name node, of the name node. And the transaction log says what is being modified. Okay, so periodically name node keeps on preparing this image periodically, but the transaction log append process is very continuous. Okay, so image is always a little bit older while logs are updated. So when the image is generated, it is called a checkpoint process. So basically name node periodically keep on creating a checkpoint by the use of I mean, periodically keeps on creating the checkpoint. All right. While the transaction logs keep on appending continuously, and that's a very common process. Even in accounting, there is general ledger and there is vouchers in the same manner. And Anindita's question is, what is the memory of name node 1, name node 2? It is up to your decision. Okay, it's up to your call. You can configure the name node to even have 128 MB memory, but not less than that. Okay, now I get Sandeep Mane's question. So no, Sandeep, we don't have an idea of a standby node for replication. It's the same data node. Okay, all right. So Sanjay is saying that so we cannot have one Linux data node and one Windows data node in the same cluster. Theoretically, Hadoop says that it should be possible, but whenever you try to install it, it keeps on giving error. Right? As of now, I have not been successful in doing it. Okay, so Shavna is saying that, all right, can we get hands-on to add on data node or remove one data node and the cluster installation like? So what you can do is if you're interested in that, you can I'll send you my referral discount. You can create on DigitalOcean and then destroy the droplet. So you will be paying only for say maybe only for few hours. Okay, so you can do that and try to install it by yourself. Okay, for me to provide that empty uh, servers will be not possible logistically. So you can try it for a couple of hours and then destroy it. Okay, you can drop me an email and then I can help you with that. All right. Now Karthik's question is, what is the name node here if all machines are data node? Okay, so good question. Good question. So basically we have installed name node and data node at Hadoop 1. Okay, so here if you look at it, if you look at Ambari, we have these four machines, and if you look at all the components that are installed on Hadoop 1, it has data node for Hadoop 1, you can see that, and you will also see somewhere there is a name node. You see the name node? Okay, so but on rest of it, it's only data node. There is no name node. Okay, does that answer your question, Karthik? Good. All right. All right. All right. Yeah. Okay. So one question is from Shavna that, yeah, if name node has smaller memory, then it will start creating bigger size. So basically, with the name node, it is very much possible to configure it to auto expand the block size. And specifically in these circumstances, when there is a very small memory left on the name node, it starts creating the blocks of bigger size. If you leave the block size to a bigger to the default value, it would start creating the block size to of a bigger sizes, so that the bigger the size, the lesser the metadata, right? Because if you have more number of blocks, if you have more number of blocks, then more metadata will be there, because for each block it will have to keep the detail of where is the block and all. So that is why it will start creating the bigger block size in the default settings. All right. Okay. So Karthik's question is, I think this is what I was trying to answer earlier. So when I log in through Hue, when you log in through Hue, you are seeing HDFS. But when you are logged in through VETI directly, you are logged into the local machine and you see the local file system. That is why. Therefore, the question arise. Therefore, that we discussed that. Okay. Therefore, we discussed in the beginning that there are multiple nodes. Therefore, Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4 all have different file system, and the fifth file system is HDFS. All right. That is why I created multiple folders everywhere. See, on Hadoop 4, on Hadoop 3, you see asgiri underscore 3, and so on. All right. You can log into different machine using SSH, and you can say this. All right. Good. Now, is there a threshold failure time for data node after which data starts replicating? Okay. Is there a threshold failure time? I think I have answered that, Tushar. There is no, I mean, there is a periodic heartbeat that is, I think, 5 seconds probably. So there is a periodic heartbeat that keeps on going from each data node. In case name node doesn't get a heartbeat from one particular data node, then it starts replicating. Okay, there is no threshold. You can say that these 5 seconds may be the threshold uh, time. So Karthik's question to what we have discussed is that, but shouldn't HDFS contain all the files from four machines? No. Okay. So although the data nodes are on Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4, but the location of the data from HDFS is different. All right. You can have a look at Ambari, and if you go into configuration, it shows you that under HDFS, and if you go into configs, I think it'll be read only for you. Okay, it shows that the name node directory is here and the data node directory is here, meaning on each of the data node, the data will be Hadoop HDFS data. This is where Hadoop HDFS and data. This is where HDFS is storing its data. You can't access this folder. If you could access, you will find inside this folder you will find the blocks, the pieces of data, not the actual data. All right. This is the normal file system. This is the normal file system as it existed before installing any data node or any Hadoop. Okay. This is the normal file system. Okay. If you don't want to have Hadoop HDFS on this machine, you can remove it. These local files will remain unimpacted. All right. If you want something to be discoverable from everywhere, put it in HDFS. Don't keep it in local file system. Okay. Local file system is only meant for temporary operations, like your usual operation, running a program. So you have to keep that binary locally. But if you want to have something replicated, then put it in HDFS. Don't keep it locally. All right. Yeah, you cannot search across all the nodes. There are utilities that help you search across the nodes, but here it will be fairly difficult to do that. Did I make sense, Karthik? Correct. Put it if you want your files to be accessible across all the nodes, put it in HDFS. Don't keep it locally. All right. Just create your folder here in the home folder. Here you create your separate folder like other people have created their folder, and then you can keep your data there. Also, don't keep any personal files here. This is mostly for learning and experimentation. All right. Now Sanjay's question is, in HDFS what is the life period of the data? Is it stored for short period time only, or only for during? No, for in HDFS, as since HDFS is fairly reliable process, you keep the data which you want to really uh, keep for longer period of time, not for temporary period of time, right? So Sanjay's question further is, why can't we update data in HDFS? Because there's only add, update and delete etc. As I told you, updating process of the data is basically you delete an old file and create a new file. Although the API does provide you a ways to edit it, but internally it essentially deletes the old file and creates the new file, because it has to it has to say you have added few more lines. Now the data has moved, and all the blocks after that point will be impacted, right? Therefore it cannot figure out so straightforward way that these are the things that have changed and therefore only these blocks need to be updated and so on. That will be very inefficient. Instead of that, it is you should basically create a fresh file. Now Tushar's question is there okay. uh, Anitha's question is, why did we keep Hadoop 1 as name node while all others? So there has to be only one name node. So we could do only two things. On one node, we install Hadoop. Say Hadoop 1 we have dedicated for name node, and Hadoop 2, 3, 4 we dedicated for data node. Now Hadoop 1's storage is not being utilized. Therefore, we installed name node and data node both on the Hadoop 1 machine. Okay, and why did we choose Hadoop 1 specifically? Because Hadoop 1 has bigger memory than the other. Okay, you can see that here in the Ambari. You can see it clearly that these out of these hosts, Hadoop 1 has the maximum 8 GB of memory. All right. Wow, this batch has got maximum number of questions. All right, I'll not. Okay, let me finish answering all of the questions. And okay, so I think it's you helpful for everybody. Sanjay's question is, the stack of HDFS software on Hadoop 1 to 4, do they all have to be the same, or some components can be different on data nodes? Some components can be different on data nodes. Okay, this is a bit of planning. So you basically do not keep too many things on one node. Okay, you can have a look at our structure the way we kept it, and this is a fairly an ideal kind of a cluster setup. So the clients such as Zookeeper client, Tez client, WebHCat client, the clients we install everywhere. Okay, while for server, for services we decide, we do a little bit of a planning, so that so that say name node and secondary name node are on two different machines. So you can see that as name node, it's a secondary name node is on Hadoop too. Pig is a client, so we have installed Pig everywhere. Scoop is a client, which we have installed it everywhere. Uzi server we have installed on three, Hadoop 2, not one, because one was getting overloaded. So some servers we install on Hadoop 1, some services we install on Hadoop 2. Some I'm using server and services interchangeably. All right. Yes. All right. Now, Sandeep Mane's question is, if I'm having four laptops connected on LAN, I should be able to similar setup, correct? Yes, you can have the similar setup if you're having four laptops. Actually, the main important aspect out of this is Hadoop 1, 2, and 3. Okay, because afterwards we will keep on repeating the same thing again and again. If you see, Hadoop 3 and Hadoop 4 is identical. The main services are installed on Hadoop 1 and Hadoop 2. So if what I'm saying is, installing on two nodes is actually more than enough and should give you an exposure. And three even better. All right. So Sarvana is saying that what if we configure the block size other than default? Then it I think it gives an error. All right. Okay. So, Karthik, did you get the answer to your question that as we cannot access data folder, you were asking related to the question related to why our all data is not automatically put into HDFS? Sanjay's question is that longer period is relative. Is it like data warehousing? So the quick answer to that is you keep both kind of data in HDFS. The data you require, you don't require too frequently, or your data which you require too frequently. The only constraint is that the data which you should be keeping in HDFS should be something which you don't modify too frequently. All right. Fitting it into a data warehouse model kind of scenario will be difficult. Okay, so basically it's a file system, and we are using this file system to store files which might be used immediately or later, or it's lying for years. Okay, so lying for years as in, even if hard disks are failing, it's automatically balancing itself. All you need to do is periodically replace the hard disk which have failed. All right. Great. So yeah, Karthik also got his answer, and now there are two more questions to go. So Suresh's question is: in real time, who will decide the hardware capacity? As our role will be data analyst and architect. So it's actually okay. This is a good question. So let me take a step back and try to explain the process. So on one hand, you have sysadmins, system administrators, okay, and then you have devs plus analysts plus data scientists, okay. So system administrators generally provision the systems, and the Hadoop is used organization wide. It is not used only for few people. So Hadoop is generally used for the whole organization. There will be many teams, many developers, many analysts, and many scientists from various teams using the same cluster. That's what we're going to discuss today. And and whenever a new project comes in, whenever there's a new project, or let me just put more people here, you have product managers and all the asterisk managers. I'll just put asterisk managers. Now, you have all different stakeholders, right? So a new project comes in, and you need to decide upon what should we inform the system administrators. So before you launch your product on the cluster, you have to inform system administrators about total number of machines you might require. Okay, or you can say that first you have to inform them that the volume of data that you want to accumulate more on the cluster. Okay, second is with respect to mr jobs with respect to mr jobs, uh, how much approximately number of CPU hours every day. Okay, if you think your job can complete in 15 seconds, 15 minutes, and here how much of CPU hours into into number of nodes. So you provide them total number of nodes with the maybe, okay, how should I say, total number of CPU hours and total number of nodes. I mean, this is generally optional because the number of nodes they already have decided. Because if your total number of CPU hours is going high, they will increase the number of nodes and divide that by that number. Okay, so basically you do a back of the envelope calculation on how much storage are you going to have, and a back of the envelope calculation on how much approximate number of CPU hours it's going to take. Okay, so if a small data like 1 gigabyte is taking 1 hour to process, and if you have 2 gigabytes and two machines, it will still take the same time to process if you have done a perfect map reduce. All right. So based on these multiple kind of computations, you need to have basically system administrators are looking out for an approximate numbers. Okay, they are not looking out for exact numbers, and this number of CPU hours tells them fairly good amount of information, because the way a provisioning works is in an organization is they increase the capacity of their cluster to 2x when they hit 75% of their existing capacity. Okay, it's a fairly common understanding with system administrators that they double the capacity when they hit 75%. Okay, so 75 or 80, I don't know, but yeah, approximately 75%. So your role is to give an approximate computation. You try to run your program locally and then multiply it by gigabytes of data it's going to process in production and scale it on paper, and then you will have a good amount of information. All right, very good question. Now we have Lloyd's question. It's a good one. All right. How do you distribute component services to the different nodes? We have a very simple solution. I would recommend the same thing to you as well, using provisioning tools such as Ambari. Okay, such as Ambari. You install Ambari on one machine, and then on all machines you install Ambari server on all machines, and all machines on the cluster, all cluster nodes, you install Ambari agent. And once you have done that, you add all those agents in here. Okay, I could show you that. Let me have a look at it if it's allowed. No, it's not allowed from this account. Let me try to log in from some other account. I could show you from here. Actually, in Ambari, you can uh, add more and more hosts as you keep on going. And while adding a host, you can specify what all services do you want to add to that particular host. Similarly, if you want to move service from one machine to another, you can use Ambari for the same thing. You can move a service from one node to another easily using Ambari. All right, it takes care of all those parts. All right, does it make sense to you, Lloyd? Great. All right, so that was very great set of questions. All right, so yeah, please go forward. If you have more questions, please ask. All right, I'll answer it after this particular discussion. So question from Sanjay is, the installation on data nodes is machine by machine, or can we install and choose which components go onto which machine? You can easily choose that these components go onto which component should go onto which machine easily. Okay. The wizard which Ambari gives you has add host. you add the list of hosts in a single shot, and then it'll give you a nice UI showing which host should have which service. Okay. Yes, we are planning to cover yarn topics that we have not yet covered. All right. Great. So moving on. All right. Any other questions at this point of time? Was I able to answer your question, Sanjay? Great. Brilliant. All right. So there is one question which is still there. Let me just finish all the questions. So Tushar is asking regarding the Hadoop HA configuration, are the general nodes separate machines, or do they reside in the active name node and standby? All right. Let me just pull it out so that we all are on the same page. All right. There was one question which was remaining from the last session. The question was related to. I did not answer that question. That also I will answer now. All right. So we were talking about this one, and the question is related to this one itself. So regarding the Hadoop HA configuration, are the general nodes separate machines, or do they reside in active name node? So general manager, I think you're talking about where is this quorum general manager, right? This is your question, isn't it? So we talked about name node and standby name node, and there's data node. Now question is where is this quorum general manager stored? Okay, so quorum general manager is stored on, it can be stored on a separate set of nodes. Ideally people store quorum general manager at a separate machine. Okay. There are standard tools like zookeeper who can act like a quorum general manager. Okay, we'll cover zookeeper later on. You will understand why do we need a dedicated system for this. Okay, the way we are switching between name node and standby seamlessly, this kind of requirement is there with multiple systems, even in your own systems. In those cases you might also require similar facility in other applications. Therefore, systems like Zookeeper do a very good job as a quorum general manager. All right. All right. So quorum general manager is general. I mean, is used as Zookeeper is used as a quorum general manager. Okay. And I think there is also a quorum general manager from HDF itself, SDFS itself, which can also be installed on other machines. Okay. So when we have a standby here, there could be multiple standbys as well. Okay, there could be multiple standbys as well. So we can, so there could be multiple standbys as well, and there will be only one which is acting right now. All right. So this is a dedicated. There are, here we talked about two things. One, the quorum general manager can, a zookeeper kind of a service can be used as a quorum general manager. Similarly, there is a dedicated quorum general manager in the HDFS 2.0, and that you need to install somewhere else. Ideally, you should be installing it somewhere else or on multiple machines parallelly. Okay. The only downside of installing a quorum general manager on name node and standby is, first, if you install quorum general manager on name node, you will be overloading name node. And if you install quorum general manager on either of these nodes anyway, you are basically hurting its availability, because in case of failure, you are going to rely on quorum general manager. In case of name node failures, you want to do that, but it's okay, kind of okay to install QJM on various data nodes. Okay, but that's not, again, that's not a great practice to have, because like asking too much from a single service. All right. There was one more thing which we discussed last time, that if you have a name node federation like this, okay, do they have common data node pool or do they have exclusive data node pool? So actually they have a common data node pool. So data from name node 1 and data from name node 2 might be stored on the same data node. All right. Good. Brilliant questions. So did I answer your question, Tushar? All right. Now, Karthik's question is how to create folders in HDFS from VETI. Good question. Can anybody answer quickly? Good, good. Thank you, Lloyd. Thank you, Lakshman. Yes. So you can use Hadoop command. There is a command called Hadoop. So you can go over to Hadoop 17. You see this Hadoop 3. This is VETI. So if you say Hadoop here, this is your gateway to the Hadoop. Okay. Right now you are standing in the Unix cell. This is Unix shell. Okay. And Hadoop command is your gateway to Hadoop. And if you are saying Hadoop FS, you want to interact with HDFS. And using these commands, you can interact with HDFS. Okay? If you don't like Hue, you can basically use this command to do all the things. Alright? And if you want to understand the purpose of every command, you can say Hadoop. Okay, you can say Hadoop FS. All right. So for individual command, you can say Hadoop fs minus help and minus tail minus stat. You can do all of that. Great. Thank you, Tushar. So basically, to create the directory, you can say Hadoop fs. It's like this. It's not minus fs. It's fs minus mkdir. All right. You can give the directory name. All right, this way. Then you can, let me just create this. Now what, it will create a folder with name called directory name. Now you go to file browser, refresh it. Do you see dir name folder? It is here. All right. Brilliant. Good, good. Any other questions before we move? This is great. This is great because uh, you will get the clarity of concepts only by trying and only by asking more and more questions. All right, sounds good to you? Great. Let's move on. All right. So till last time we only talked about the file system. Now we all are convinced that HDFS file system is good enough for storing petabytes of data with in a very comfortable manner. Okay? That's where once you have done storing the files, next thing you want to do with the data is process it, because that's the reason you might have stored the data. Now processing, the way in the Hadoop 1.0, the processing was done under the name called MR, MapReduce. Okay, internally it does a lot of computation, but let's try to first understand how does the execution happen. Okay, so everything was under MapReduce being a programming paradigm as well as being a resource management. So MapReduce was doing everything. All right, and what was it doing under the hood is there was job tracker and there were task trackers. We used to ask job tracker to get something done, and job tracker would take your work, get it done on multiple machines, and give you the result back. That is how the work got done. So if you have a very big work to be done, you ask job tracker to get it done on multiple machines. Now, there are many questions that would be arising in your mind. Okay, keep on asking those, and as we go forward, you will get those answers cleared. So we ask job tracker to get our work done on multiple machines. Okay, so so basically we utilize the CPU and the RAM of multiple machines. Now, generally this task tracker is also installed on the same machine as the data node. So in case the file you are processing, if section of that file is available on the same node as the task tracker, it can take the benefit, and it used to take the benefit. Therefore, whenever we asked MapReduce to get something done, we gave it a big file. We uploaded our file into HDFS and told our MapReduce that this is the file which we want to process, and please process it. And based on where all this file is existing, where all the blocks of these files are existing in HDFS, it used to execute our processes near to our data, which means sections of data are being processed by multiple task trackers parallelly. Okay, so you have a big file to process, you have a big table, or you can say that if you have a big file to process, you are processing partial data in each individual task trackers and then merging it and giving the results back to the user. And that's what, so in other way, you can also visualize it like this. There are many clients to job tracker. Job tracker is asking the work to be done by the task tracker. And once the task tracker is done with the work, they inform the job tracker, and job tracker once all the task trackers have finished the job, finished informing job tracker will confirm to the client that hey, your work is done. Or client can also ping job tracker from time to time and ask, is my work done? Okay. So basically, client keeps on pinging the job tracker service that hey, can you tell me if my work is done or not? So let me repeat again. So client asks job tracker to get the work done. While asking the job tracker that get my work done, it used to tell the job tracker that hey, here is my file and here is my code, please execute this code for this file. Now it will execute your code against sections of this file on multiple task trackers. All right, all right. Now let me describe in a little bit more details. So the user or the user, you like you will first upload the data which you want to process in the HDFS. All right. And then you will create something like a job. Create something like a job. And jobs definition contains first, what file do you want to process? Then the logic you want to execute on every node. Third thing you specify is the logic you want to execute in order to combine all the results from all the nodes. So you specify three things. First, which file do you want to process? Second, what is the logic you want to execute on each individual job trackers? And third thing you want to specify as part of job definition that how is my data going to get combined? All right. So that was MapReduce. So you basically first uploaded the files. Second, submits the job. You submitted the job to the client. Now client will create something called splits and find out which all job trackers have the file which you are talking about. And again, think about it again. So the way an HDFS file is stored in HDFS is in form of small pieces of data. And these pieces of data are existing on multiple machines. So if you think about it, if you are processing a file, it is far more beneficial to get the work done on the same data node on which the blocks are stored. If your blocks are only stored on say 5 nodes out of 100 nodes, so it makes more sense to get the work done on the same machine instead of transferring the data from that data node to some other node and processing it. Meaning, again, coming back to my analogy of carrying the code to the data, here again, there are multiple things happening. First, we are utilizing multiple machines to execute our logic. To get our work done, we are utilizing multiple machines. Second, what is the second thing which we are utilizing? The RAM of all the machines, the processing ability of all the machines is being utilized. Third thing, we are utilizing the fact that the data is stored locally. So the disk read write are distributed and we are minimizing. The fourth thing which we are doing is we are minimizing the network transmission of the data. So we got four different benefits of having Hadoop. We utilized multiple CPU, we utilized multiple RAM, we utilized the multiple hard disks parallelly. So if you remember our discussion earlier that reading a file, reading 1 TB data takes approximately 6 hours, right? And if you have 1,000 computers, then that 6 hours will be 6 by 1,000 hours, right? So it'll come out to be hardly few maybe 13 seconds if you have 1,000 computers hosting these many files. Okay, if you try to distribute the work. Now, and basically we are trying to utilize multiple computers disk in order to give you the data. Okay, so does it make sense? Did I make any sense? So we are utilizing CPU, RAM, disk IOs, as well as the proximity to the data using Hadoop. And that's how it performs the work really, really fast. Okay, we submit the job, Hadoop takes it from us and gets it done on various task trackers. All right, let me complete and then I'll answer your questions. All right. So right now I'm detailing you with respect to Hadoop 1.0. So the user submits, first of all, whenever you deal with big data files. Okay. Also, all of you, please keep in mind that we use Hadoop not to improve our quality of code, not to improve the developer productivity. We use Hadoop in order to get the work done really, really fast. I mean, get work done on big data really fast. Okay, so you whenever you are processing a file, generally the files which you are processing on Hadoop is of considerable amount of size, so it is imperative that you will upload it on HDFS already, or you are processing a file which is already on HDFS. Okay, second, you submit a job and as part of job description you tell, you mention which file you want to process, what is the logic means a piece of code, a piece of either in compiled format or in a script format. So a piece of code, you mention that this should be executed on all the machine on top of my data. Okay, now this client is the Hadoop client. You saw that if you say Hadoop jar, it will try to execute your program as okay, as Hadoop MapReduce job. So it is this Hadoop client, Hadoop jar, the command line which we were using just now for Hadoop FS. So this client finds out where are the blocks and creates something called splits for the execution. Now it client this command line, the command line library submits the job which you submitted to the client. It submits the job to the job tracker, and job tracker creates something called a job queue. It's very natural that if you have multiple people working on the same task, you will create basically a accounting system in the form of whether queues or slots or whatever you want to call it. If you have visited a hotel where there are so many waiters and so many tables, and every table is ordering something, and there is only single kitchen, in all those cases you have a concept of a queue, right? In the similar manner, job tracker creates a job queue for each of the job, and this job queue keeps a track of which node has finished the work. Okay, it is for the accounting of the data nodes. Okay, so job tracker, before handing over the work to data nodes, creates something called a job queue in which it will keep a track of which 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 node has finished the work and which are still working on that. And in case some of the job tracker, as in the one who was working on the task, has failed, sorry, some of the task tracker, something which is working on the task, if one of the task tracker has failed, then it will assign the same work Job tracker will assign the same work which it assigned earlier to the one who has failed. It will assign that same work to somebody else. Okay, it'll and it will basically not, I mean, it will find out which machine is having the same data as the one which has lost, and will execute the logic near to that machine. So it will try its best to find a task tracker, find a machine where your data is located. Okay, if your data is not located on the machine which is free, then that's also possible. So as your each block is going to have multiple copies, there are high chances that you will find some task tracker containing the data. In case it doesn't, it will try to first execute it on the same rack, otherwise on the same uh, data center. All right, it will try its best to execute it near the node. All right, whether on the same node, or if same node is not available, it will try to execute on the same rack, as in an Almira, in which is a local network in itself. Or if it is not able to execute it on the same rack, it will try to execute it on the same data center. I'll explain to you how does that happen uh, at later point of time. All right, let me take your questions now. So Sanjay's question is MapReduce the only framework available for parallel programming? No. There are Spark, there are Storm, there are hundreds of similar platforms. But MapReduce as a paradigm is something which has been inherited from functional programming language. I very well remember in 2002, when we were working on large cluster, our definition of map and reduce were that of a functional programming. We used to use our Perl script on our cluster to execute map and reduce, and we had a 10,000 node cluster. So although MapReduce sounds like a common mechanism, and MapReduce sounds like the only solution, but no. MapReduce, although if you go with Spark, as we will discuss in session number 10, you will notice that there is also MapReduce, but that does not mean that MapReduce is the only solution. Okay, good question. But the concept wise, MapReduce is a very good concept, and it's a very good way of executing any logic near the data. Whenever you want to execute a logic on top of data, when data is bigger, the same concept of MapReduce is applied everywhere. All right, like saying, in case of R or in case of other programming language, execute this piece of code on every row in my table. All right, like we run the projections in SQL query. In the similar manner, we run map. Ravikant is saying that, can you explain with an example? Do you mean how does this work? All right, Ravikant, just don't worry, we will go into details. Okay, we'll go into details with multiple kinds of example of exactly what you're talking about just now. Okay, no worries. Now, next question is, does the approach and complexity of problem? Yes. So Sanjay's question is, does the approach and complexity of problem changes in MapReduce framework compared to traditional programming language? Yes. It changes actually considerably. The way if you had moved from programming background to SQL, when you shifted from programming background to SQL, you stopped thinking in terms of loops and conditions. Instead, you started thinking in terms of records and sets, right? When we started working on SQL, in the similar manner, when you start working on MapReduce, you start thinking in terms of maps and reduces. What need to be executed on every node and what need to be used for aggregating the data across all the task trackers. So complexity definitely increases. So the complexity definitely increases as we move to MapReduce framework. Complexity increases because it takes a little bit of time to break a logic into MapReduce. But luckily, as of today, there are components which basically do the translation of SQL into the MapReduce. Okay, so a lot of complexity is absorbed by them. Okay, so eighth step is done by task trackers. We are talking about this diagram. Yes. So job tracker also reads the job description file. No, this job tracker is okay. So job tracker is reading the job description file and accordingly creating the maps and reduces. Job description file as in what does the logic states. Okay. And once that is done, the actual work is being done by various task trackers. Okay. So here the assignment is happening and afterwards job tracker is giving the work to many task trackers, and in case heartbeat is not received from one of the task trackers, the work is given by some to somebody else. All right, let's have a break time. And somebody is suggesting for a 15 minutes break. Is that okay? So you want a 15 minutes break or 10 minutes break? Yeah, feel free if you have. Yeah, I'll just see. So 15 minutes or 10 minutes quickly. All right, looks like 15 is winning. All right, let's take a 15 minutes break. Back by 10:22 p.m. IST. All right. Should we start now? Are you back? All right, great. All right. So let's go over it once more. So a user submits the job, first uploads his data onto HDFS. DFS and HDFS is the same thing. So the input files which user wants to process, he has put it on the DFS or HDFS, and afterwards he has created a job and which is being submitted to the client. And this job contains the information about which files need to be processed and what logic has to be executed on every node. Okay, so client basically finds out where is this file located on the file system, and then based on that it creates something called input splits based on each block. So you can think of each input split is equivalent of each block as of now. So it finds out where is the data, and accordingly, sorry, this information is not done by client, actually it is done by job tracker. So there is a minor mistake here. So job tracker does the input split finding. Okay, this needs to be corrected. This arrow has to be from the job tracker side. Okay, all right. Now once job tracker has found out which all blocks need to be processed, which all blocks belong to that file, and where all these blocks located, meaning which all task trackers contain these blocks, or which, if there is I mean all the three copies of a block are busy, if all the three copies of the block, if all the nodes on which the copies of the blocks are allocated, if all of those nodes are busy, then it will try to find the task tracker which is closer to the data, not the same as the eh, not on the same machine, but nearby, and then it will try to execute the logic there. Okay, so to execute the logic, it will first create something called a job queue and assign the work to various task trackers. And those task trackers will start processing the set of blocks using the submitted definition of the work. It will start executing. All of these task trackers are working in parallel, processing sections of the data, processing blocks of the data, and then once the result is done, the job tracker is informed, and once job tracker has finished the work, it informs the user. In case any of these task tracker fails, the work is delegated to some other task tracker who is closer to the data. So Sanjay's question is, does job tracker interact with the name node? Yes. So whenever you are executing a job tracker, whenever you are executing a job here, whenever you are submitting the job to the job tracker, you also inform the job tracker that where is the name node. So you only need to inform about the name node, and it will gather rest of the information from the name node. All right. All right. So right now, Sandeep, what you can see is that we will discuss in detail. Basically, when you submit a work to MapReduce, you submit in the form of two kind of functions. One is called map function, other is called reduce function. So map function is executed on each record in the input data. Okay, map function is executed on each record of the data, and once all these records have been processed, the combination, as in like you have aggregation in case of group by, that kind of aggregation will happen through the reduce function. You will understand more when we go through map reduce in detail. Okay, right now let's focus on this job tracker and task tracker. We'll go into the details of semantics of MapReduce. We'll do it later. All right. So this is how MapReduce 1.0 used to work. Again, this is what is happening. But after in the Hadoop 2.0, in Hadoop 1.0, there were only two parts. One was called HDFS, other was called MapReduce. Okay. In the core Hadoop 1.0, there were only single component called MapReduce and single component called HDFS. So HDFS was responsible for storing, MapReduce was responsible for processing the data. Now, so MapReduce used to do everything. It used to do the cluster resource management, as in job tracker and task tracker, as well as the only way of executing your logic was in the form of maps and reduces. There was only one framework possible. Okay, so there was nothing, no other framework was possible earlier at that point of time. So a major revamp happened in if when Hadoop moved to 2.0, and the Murthy, who is a founder of Hottenworks, was did this major change from Hadoop 1.0 to Hadoop 2.0, whereby whereby what he did smartly is he broke MapReduce into two parts. The one portion of MapReduce was basically semantics of what goes into map, what goes into reduce, and what happens inside maps and what happens in reduce. So one portion was that, other was resource management, which task tracker is free, which job tracker is free, that kind of model. So MapReduce was broken down into two parts. The resource management part is called yarn, and this basically made it possible for new paradigms to be executed on top of yarn and HDFS. This gave a way for new generation of new sets of paradigms of computation, not only MapReduce. This earlier one, since there was a single monolithical component called MapReduce, monolithical as in made of a single stone. You must have seen those carved statues made of a single stone. So MapReduce was the same way, that it does the resource management as well as it executes maps and reduces, and therefore it was not scalable. So it was broken down into two parts. One is called yarn, another is called MapReduce 2. And this MapReduce 2 does only the execution of maps and reduces, but rest of the things like finding out which nodes are alive, which nodes are dead, getting creating the queue of execution, all of this is done at yarn level. All right, so this basically gave a way to gave a way to lot of new frameworks. So one, Tez came into picture. What does Tez do is, Tez is basically a SQL execution engine. So MapReduce continued to be the same. Tez also started using HDFS and yarn. HBase also came into play, which also runs on top of yarn. Streaming like Storm and S4 and everything, those also run on top of yarn. Giraffe, in-memory Spark, and so many newer frameworks came into play which could run on top of basics of yarn. Okay, so I think this was, I think, Sanjay's question, right? Is this the only way to to do the computation, right? So this way, the MapReduce was broken down into two parts. One is pure paradigm and processing engine. Other part is the resource management. Resource management as in which system is free, which system is busy, which one should be queued, which one should not be queued, and so on. All right. That became Yarn. Yes, Karthik. Hadoop 2.0 is no longer in production. Nobody is using Hadoop. Sorry. Hadoop 1.0 is no longer in production. Everybody is using Hadoop 2.0. All right. Now I'll go into a little bit more details into Yarn. If you have more questions about this breakdown, I'd like to take this up. Yeah. So Sarvana's question is, that means there is no job tracker and task tracker in Hadoop 2. That's correct. They have been renamed. I'll go into the details right away. So Sanjay's question is, there is HDFS and HDFS 2.2. Yes. So the HA, high availability kind of features, are only HA and Federation is only in 2.0, HDFS 2.0. So Karthik's question is, uh, HBase is a HBase is a SQL interface? No, HBase is just a very big database which can on which you can run MapReduce. Okay, in HBase you can store data in tables, and on top of tables you can run MapReduce. All right. So yes. So Jairam's question is, please explain. So I will go into the MapReduce jobs in a very much detailed fashion. So do not worry about it. Right now we are trying to compare the resource management. All right. Once we are through with the resource management, then we go into the programming model. All right. Yes. So next question from that Karthik is that the HBase and SQL, HBase and these things are being displayed on the same level. That's correct. Because as I was telling you, there is one MapReduce which runs on plain HDFS files. Then there is another MapReduce that can run on HBase tables. That's why they are considered on the same level. Similarly, HBase itself, for finding out the resources and to store its data, it asks yarn and asks which one is free. Okay, so many services use yarn in many possible ways. All right, does it make sense to you, Karthik? All right, all right. So this yarn is a very important change in the history of Hadoop. Otherwise Hadoop could have been deprecated by now. Now, Vidya's question is Yarn a task tracker? No. So, basically, Yarn is a framework. Yarn is a framework. I will come to it. You will be able to understand it. So, all right. So yarn basically supports for workloads other than MapReduce. That means MapReduce is not only the way to get the work done. There are new paradigms and that can be supported on top of yarn. And probably because of yarn as of today, Spark is running really well on top of Hadoop. Second is scalability. Okay, the reason why yarn was implemented is to support multiple workloads than the MapReduce. Scalability, as in more and more applications can be built. Also, the one more important part that happened during yarn, the code which was written for MapReduce 1.0 was still valid for MapReduce 2.0. All you need to do is recompile it and it will work fine with Hadoop 2.0. It's like backward compatibility thing. Yarn was mainly an internal change. If you think about your MapReduce logic and MapReduce code, Yarn was just internal change. It did not impact your MapReduce code. It improved the cluster utilization. Why? Because if you have many machines and there are many components running parallelly, it will utilize the cluster really well. Agility, as in the change became easier because it was possible to write your own framework if none of the existing framework is doing the justice. Next was MapReduce was batch oriented. Earlier MapReduce was really slow and was batch oriented. So Yarn improved upon that. So the nomenclature changes happen this way. Tracker became resource manager. Resource manager is the central one. And then application master and timeline server are two more components which were added. Task tracker became node manager. Actually, I was planning to keep only Hadoop 2.0, but then it became sort of important to give a description of Hadoop 1.0 as well. All right. So job tracker, the central agent became was renamed to resource manager because there was a major overhaul in the behavior. Task tracker became node manager. All right. The next diagram will explain it a better way. So Sanjay's question is, so yarn cannot be skipped by Tej, HBase etc to interact. No, that's not what this diagram is about. Okay, so all right, it's actually a very valid question. So Sanjay's question is, so as per this diagram, it seems that if MapReduce has to talk to HDFS, it cannot do. None of these processes can talk to HDFS directly. That's not true. Okay, it's just for the diagram sake we have created in the same manner because yarn also uses HDFS and all. Also, all of these processes, when they want to find out a file's block, instead of talking to HDFS, they generally ask yarn that can you give me free nodes which are hosting this particular files. Now yarn knows which nodes are free, and yarn also knows where are the blocks of the files located. Therefore yarn can answer better in terms of which nodes are free as compared to HDFS. All right, but in case your program directly wants to read HDFS, it is free to do so. All right, this diagram will make it a little bit clear. So you can see that what we used to call a job tracker is now called resource manager. It is the central agent which manages and allocates the cluster resources. It's the central agent, as in you want to find out which machines are free. You want to find out which which one is very busy and so on, or you want to find out that the machines which are closer to this particular file which can execute something. So all of that information is available with resource manager, and resource manager controls everything. If it wants to, abandon a node manager, as in it assigned something to node manager, it can abandon it at any point of time. So resource manager is the most important service out of this. Now there is something called node manager. Now node manager is per node agent, meaning on every machine in your cluster, if you want to get something done on that node, you have to install node manager on that. Okay, although when you install the full Hadoop, it gets installed automatically. Okay, now there is new thing called app master. Earlier there was only one thing called MapReduce, right? So it was hard coded as part of the whole node manager, right? Now instead of that, now there's something called app master and a container. So container basically talks to other to various app masters and get the work done. Okay, so container controls app master, and app master is something which executes MapReduce, HBase, Spark, and various kinds of things. So there will be one app master. There will be multiple app masters. One app master dedicated for MapReduce, one app master dedicated for dedicated for Spark, and so on. All right. So this way, so there are many application masters. If you want to build your own new framework, you will create your own app master. Although that would never be required. That will not be required as of now because there are so many frameworks already available. So Shravana's question is, so Yarn is only for processing? Yes. Yarn is only for resource management, and processing is done by various add-on on top of Yarn. Okay, so Tushar says that does Yarn takes the information from name node for finding out location of blocks. That's correct. Yarn, when we are launching Yarn, we inform Yarn about the name node, and then it will basically gather all that information. So Karthik's question is, App Master is part of Node Manager? Manager? Yes. So on each node, the actual work is done by App Master, because App Master is uh, there is one copy of each App Master. There will be something called Spark App Master. There will be something called HBase App Master. Then there will be something called MapReduce App Master. So these will be executed. They do the actual work of execution on each node. So question is, where does the resource manager reside? Is it in the name node or job tracker? Generally on an independent node. So resource manager does not necessarily need to be on the name node, right? In on top of HDFS, it doesn't need to be on name node. Just for pictorial purpose, we showed it in the earlier diagram that it is on the name node. But it is preferable to have separate resource manager. And in case of our cluster, we are hosting resource manager and name node on the same machine. It's generally not advisable in production environment. Why? Because resource manager itself is a very intensive process. Resource manager is a very intensive process. And same is the name node. So you do not want to overburden one particular node. All right. Lloyd and Sanjay's question is, what does container contain? Container is basically ensuring that app master does not cross its security limits. Okay. Container's duty is to ensuring that each app master, these app masters do not cross their boundaries. Container ensures the security of, of the node manager. Yes. So Tushar's question is, so as per the application we require to work with, the respective application masters get automatically activated. When we submit a job on Yarn, whenever we'll submit a job on Yarn, it would internally carry that app master and get it executed over the Hadoop cluster. So Lakshman's question is, if there are multiple jobs run on the same data node, are they executed by one app master? Yes. There are multiple instances of app master for each map reduce, because not only you, but there could be many other users of of MapReduce who are doing the things parallelly. Okay, so there are multiple instances of app master. No. So job tracker also never it just pictorially we represented as if the job tracker is on the same node. Okay, it's just the pictorially we represented. Ideally, job tracker is generally kept on different than the name node for the same reason that job tracker, the work of job tracker and name node both are very heavy weight works. Therefore, it makes sense to separate them on two machines. Also, the communication that happens between yarn and name node is not too data intensive. Okay, it's not too data intensive. Now question from Sanjay is that why is container from one node pointing to app master? It can be either way. It can be either way. So the container's duty is to ensuring the security. It could have been on the same node as well. All right, but task trackers, and thank you Sarvnath for asking that. So although job tracker and name node are generally kept on different node, but task trackers task tracker slash node manager are generally on data node. Okay, are generally on data node. Why? Because the objective of churning big data is to avoid transfer of the data. If task manager and data nodes are on different nodes, there'll be always the data transfer happening over the network in order to get it processed, and therefore it will become very slow. Makes sense to all of you? Did I answer your question, Sarna? Great. All right. All right. Any questions at this point? Although this diagram looks really complex, but it's not much. Okay. It's not too much complex. The idea is quite simple. So Tushar's further question is, does each data node have both app master and container? That's correct. But I mean, the app master always. So there are so many node managers, and app master will get some of the node will contain MapReduce app master. Some of them might contain Spark app master, and so on, depending on the availability of nodes, depending on the availability of the nodes. All right. So Karthik's further question is, can you explain more about container? We will see it a little later also. All right. So you can see that inside a node manager, probably this will give you a little bit more details. So you are the client, okay? You are the client and you are submitting your work to the resource manager. Resource manager will talk to all the node managers and will execute inside the container. It will execute the application process, okay? And if required, it will also talk to other node managers in order to get your work done. Whenever required, it will launch more and more containers in order to do a processing on multiple machines. Now does it make sense, Karthik? Now next question from Lloyd is that, does container care about application types? No, because container can execute any kind of any kind of application master inside it. All right. So next question from Sanjay is, can MapReduce app master interact with MapReduce app master on another node to process the job? Yes. So I mean, though the MapReduce framework does not allow it, but as per Yan, it's okay for one app master of one app should be able to talk to the another app master of the same node, same app. So MapReduce app master can talk to other MapReduce app master, but MapReduce itself does not allow that kind of thing. Okay, MapReduce framework does not allow that. You will see that later why it doesn't do that. So in this, the application process is the app master in this diagram. Now Karthik's question is, jobs submitted to Yarn will only be related to finding files and not processing it as data processing is done one above Yarn. Okay, so yes, it's a good question. Let me explain in a little bit more detail. You will understand it a little bit more when I talk after maybe the next. I think let me talk about it after the next slide. Right? You will understand that better. So, in case of Yarn, the nomenclature changed. There was something called resource manager and there was something called node manager. Node manager execute multiple application masters inside a container. All right. Now, a little bit anatomy of Yarn. So, as I was telling you that basically various kinds of platforms, various kinds of frameworks use Yarn. So use Yarn as in MapReduce will be talking to Yarn. You will not be interacting with Yarn. You will be interacting with Yarn not directly but through the API, through the existing frameworks. So these frameworks, when they request something to Yarn, so let's say Spark is talking to Yarn, it will create something called a resource request. And a resource request includes number of containers, okay, how many machine does it require for processing, that's a heuristics, and what is the memory of and CPU of each of these containers, and what are the locality constraints. So when MapReduce is talking to Yarn, it sends a request saying that these many machines, this CPU, and this is our locality constraint, as in our data has to be nearby this node. As well as the MapReduce can ask for all of these resources upfront, or it could be flexible, as in we will ask for more resources when we need. If our current cluster does not, if our current requirement is not fulfilled by current set of machines provided, it will expand to more. So when MapReduce or Spark is talking to Yarn, they send a request with all the requirements and Yarn responds to them giving all these details and getting their work done. All right. Now when you are sending something to Yarn, there could be many kind of jobs. The job could be and the job could be of very various kinds. First is the most simple one, in which there is one application per user in the form of MapReduce, and there is second one which is one application per workflow, okay, or per user session. So that is a kind of Spark kind of job. So when Spark is talking to Yarn, it creates the jobs which are long running. Now there is some other kind of jobs such as Impala, which keep on running in the background forever. They never shut down. Or so those are called always on. One is smallest, like MapReduce. There is some long running, which have multiple jobs to be run uh, in certain sequence. And the last one is always on. So Yarn doesn't mind. The Yarn doesn't mind what kind of job it's running, as long as the request includes it. If request from the framework to Yarn says that I want an always running process, Yarn is okay with that. Otherwise, it will kill it. All right. So there's few questions. Let me answer those questions. As resource manager allocates resources, I'm confused as Y container into a points for a launch of container in another. So container is basically roaming container. Okay, and in diagram it has been displayed it that way. So all this diagram is trying to say is container is basically a boundary. Container is basically a boundary check. So whenever application master is doing something, it talks to the container and get the work done. But application master, I mean, is container is not really like a processor. Okay, container is more like boundaries through which API calls are being made by app master. And it is just ensuring that even if app master is running somewhere else and container is running somewhere else, it will still be able to execute things. All right. Now, question from Sarvana is how will MapReduce decide that how many resources does it need? Okay, so MapReduce knows how big is the file, and based on that it can decide as in how many machines are required. So if we when we talk about in future, there are some tools such as pig which decide upon number of machines to be utilized based on the input data. Okay, so basically number of resources are a function, generally a function of total number of blocks or how big is the file. And sometimes number of nodes can also be specified by you. You can specifically say that execute this thing on multiple machines. All right, does it make sense to you? All right, now if you want to build your own yarn application, first it's a very complex process to build a new yarn application. Okay, therefore it's not something which is targeted to a general Hadoop developer. Okay, so if you really want to build yarn application, first you don't need it because there are so many frameworks already there. Second, try to utilize existing tools to build the job, such as Apache Slider can execute any program which runs outside Hadoop, it can run it inside Hadoop as well. Then Apache Twill is a Java runnable, as in you can implement something like a runnable the way you run it a thread. Similarly, you can anything that can run as a thread can run inside yarn. Okay, so that's a Apache Twill you can use. In case none of these fit the bill, you can finally go ahead and create your yarn application. And the best way to the best starting point for building your own yarn application is using a bundled example with yarn called distributed shell application. Okay, have a look at that, and then you can write your own yarn application just like MapReduce or Spark or HBase. You can write your own yarn application. Make sense? So that was a little bit more detail into the yarn, but we'll not be interacting with yarn. It is just required to do couple of, you know, you have to have an understanding of what is yarn and what is MapReduce. That's why we have dived into detail of yarn. All right. All right, I think everybody is able to has been able to go through the cluster. Everybody understand Ambari, everybody understand Hue, and we are able to connect to the cluster using SSH. Please create your directory and try to copy some data into HDFS. Okay, so if you are trying to copy the data, all right, let me ask you a question, all of you. If you have to copy data to Hadoop 3's local folder from your desktop, what will you do? So basically, we have to say we have to take our data here. What will you do? Anybody? Good, very good answers. All right, I'm impressed. Okay, so Lakshman says that use FileZilla. Good. So we can basically, if you are on your local machine and you're on Windows, you can use WinSCP to copy data from your laptop to Hadoop 3. Okay. If you are on Unix or Ubuntu, you can use SCP. Okay, you can use SCP to copy data from your laptop to Hadoop 3. Good. Sarna says that upload the data. Okay. All right. All right. So other way, one is directly copying data using SCP. Other way is first upload data into HDFS here and then do Hadoop here inside Hadoop 3. You say Hadoop fs copy to local, and that's how you can copy the data from inside of Hadoop to this folder. Okay, let me try to copy movies.csv locally. Okay, we can say copy to local, copy to fs, copy to local. And what was movies.csv? And oh, it's already there. There is already one file. Let me copy it to my own folder. I'll, instead of saying dot dot means current directory, I'll say asgiri underscore 3. Alright, you can see that the data has been copied from HDFS to here. Brilliant. Brilliant. Thank you, Lloyd. Thank you, David. Good. David is saying use SCP. Jairam is saying SCP. Okay. Suresh is saying copy command. Good. And correct, Karthik. Good. Alright, Lakshman is also saying that copy it to HDFS and then do copy to local. Actually, copy to local is a good way. Reason being, then you don't have to install anything. If you're on Windows, you don't have to install anything. You just upload the data into HDFS and do the copy to local. Lloyd, I think you'll have to use get command rather than Hadoop fs get. Rather than put, you have to use get. Good, good. Okay, you're right. All right. Great, great. So I think everybody got it, how to copy the data. So this is, I think, clear to everyone. All right. You can connect to this or use this is not really updated. Okay. Here, ideally, it should be, simple answer should be use VETI so that you don't have to install anything. Great. All right. So you can also create your file. You can create your file from local to SGRI in the, let me try to show you what I'm trying to do. Let's say we have a local file. So let's say we have this here. Let's say we want to copy all these pig log files to HDFS. So what we'll do, Hadoop fs copy from local pig star.log into SGRI. What does it say? It has copied the data. Now let's go into my folder SGRI. You can see all the pig files have been copied from my local folder to here. Good. This demo we have already done. How to see the, I think you should do, try, all of you should try this thing by yourself. Okay. Changing the, you can use Hadoop fs command to change the replication factor. All right. So Sanjay's question is, there is no visual tool to copy or move files from local to HDFS. The answer is no. The answer is right now no. But if you are on Windows, then maybe you can. Uh, all right, because this Hadoop 3 we do not have installed any UI in that. Otherwise, on Hadoop 3, if you SSH, you could run Chrome, and from there you can access Hue. Okay, Hue would have been the way to talk to the visually. All right, does that answer your question, Sanjay? Okay, but let me just put it here. All right, great. All right, so I think we have gone over this already. Now next is that let's try to do the word count just for the demo purposes. Okay. All right. Let me just take this and then try to execute it. And the command is here. And so we are saying, so this is a library examples code which is given by Hadoop, guys, and this is how you execute your MapReduce job. Okay, if you do not understand it, do not worry about it at all. Okay, this is the input folder, this is the output folder, and this is the input folder. Okay, let's try to execute this. Let's try to execute this on the server. Okay, let's first go to our WTTY. Okay, it says that this is an example which is provided by Hadoop people. All it will do is execute word count on various nodes. All right, for the example sake, I have put a lot of data in slash data in HDFS. Here you see slash data. I have put the data whichever is required over here. There should be one folder under MR called word count, and there is something called big.txt. Inside input also you'll find only the big.txt. Okay, let me just delete this one. Oh, you don't have permission to delete. Yeah, so this data folder is common for all the students. So what we can do is we can say input. So this is our input folder. All right, all we are trying to do is count the number of words in this folder. In this folder you see this file. We want to do the word count, as in the counts of distinct words. All right, so our input folder is this, and our output folder, let me just put it as Giri slash out. Since I am not starting it with a slash, which means it's a relative path and relative to my home folder in HDFS. So it is starting to process it. So I'm trying to execute a sample map reduce for doing the word count on our cluster. So you can see that it has started the resource manager. It has connected to the resource manager, located there, and has finished the work. And the folder I gave is my home folder. What is that folder? Here you see Asgiri. Here there is an output folder which is just created, and it has done the word count for me. See that? It shows that all has come 58 times. Right, it has done the word count. This is how you run. What is more important is to understand, to run your MapReduce logic you use Hadoop jar. Okay, Hadoop jar command, and this is something which is given an example, but it is you who will be creating this jar. Make sense to you? All right, so today I want you to go with couple of questions. And before that, let me just go through, if you have, so no questions so far. Correct, that is correct, Karthik. So Karthik's question is, we did not specify while dealing with, let me just close this terminal. While dealing with this map reduce, we specified folder here. We did not specify file. It means no matter how many files are there in that folder, all of those will be concatenated and word count will be done on top of all those files. Correct. All right, that's correct. Now moving on. So this is how you can do that. Do the MapReduce. Okay, we will go into detail as in how to create your own MapReduce and how to think in terms of MapReduce. Yes, you can specify file name also. Okay, let me try to specify. So we could also say slash big.txt. So it says that output folder already exists. So keep that in mind. The output folder has to be fresh. All right. Good. Also, as soon as the job starts, it gives you a URL to track the job. Okay. It gives you a URL to track the job. You can see what's going on and which nodes are busy, what's happening, and so on. All right. So it has finished the job. These are the statistics about the program, as in how much time it has taken for various things. Good. All right. So let's start with our MapReduce things. Is everybody ready, or you have any questions? We will go through a detailed discussion on how to convert your problem into MapReduce. Okay? It's very important. It's not because of the MapReduce framework, but the same psyche or same way of thinking will matter in almost every big data problem. Okay? Be it Storm, be it Spark, be it any other framework which deals in distributed computing, these techniques will come very handy to you. All right. Now here is the question for all of you. If you have a plain text file of all of the Lord of the Ring books, say around, let me just put some number here. Let's say 50 MB. Okay, how would you find the frequencies of words? Anyone? Frequency of word means the number of times each of the unique word has occurred in this file. Are you with me? For example, this is a cow, this is a goat. Okay, so this has comes twice, is twice, a is twice, cow is one, and goat is one. So this is the result we are expecting given this big data. So Shravan says that read the file line by line and then split each word by tab. All right, good. Sanjay says take each word and count separately, sort similar words and combine all similar words. Okay, okay. Pratibha says that each word as hashmap key and occurrence as the value. Brilliant. Create a, and Karthik says create a map in Java with the key as word and count as the value and run in the loop. Good. Brilliant. Split the each word by tab. Okay. So Shravana, all right. Shravana says that create a vector or array of all unique words and then count. Brilliant. Any other? Good. Lloyd says read the text file, split the words, group the word, and then count. Brilliant. Brilliant. Okay, okay. This is something interesting. Any other? Vidya says that find the frequency in the chunks in each of the data node and then add them up. Brilliant. This is a little, you're just jumping a little bit ahead, but that's okay. All right, all right. But honestly, tell me this: if your boss asked you to do this, what will you do quickly? In your office, if some senior person asks the same thing, that get it done in an hour, what will you do quickly? Yeah. Sandeep says run away. Okay. All right. Mm-hmm. Lloyd says use Linux awk. Brilliant. All right. If somebody asks me this, I'll just open it in a text editor and control F and replace space with new line and then import the data into either database and then group by or do something else. Okay. So yeah. Sandeep says run away. Sanjay says delegate it to somebody else. And all right. So I was just interviewing somebody, and I asked somebody in interview that would you use inheritance or will you use will you use interface or will you use abstract class? So the person replied to me whatever my boss asked. If my boss asks to create an interface, I'll create interface. Otherwise, I'll create abstract class. All right. Good. Now, Ravikant says that read file line by line, start sorting each new word, putting good. So probably most of you are pointing to this. Now, question to you is, okay, let me explain the approach. Create a frequency hash table, okay, as a dictionary. It's an in-memory hash table, and the quality of this dictionary is finding a word or finding a word is very quick. Okay, finding a word is very quick, just like finding a particular element in an array is very quick. You can quickly jump to ith element in an array. If you want to update an array's 120th value, you can quickly do that. In the similar way, you can find the word in the dictionary. Okay, dictionary is a data structure, or it's also called a hash table. So you create a frequency hash table, and for each word in the file, we keep on increasing the value in the hash table. By default, every word's initial value is 1, and then we keep on increasing. Okay? If if this word is found in this dictionary, we increase its value. Otherwise, we insert this new word into the dictionary with initial value as 1. And when no more words are left in this file, you print the data which has been accumulating in our hash table. Okay, so basically you go through the file, you create this hash table or dictionary, and once you are done with it, you print the value in what was there inside the dictionary. Do you see any problem with this approach? Let's discuss it tomorrow in detail. All right, great. All right, hello. All right, Suresh. Okay. Suresh wants to watch Bahubali tomorrow. Alright, so yeah, Bahubali can probably think in terms of map reduce very well. Can, alright. Good, good. We have got good questions. So, Lux, can you keep your answer till tomorrow? And we will have discussion again in the details. Alright. So probably the way we are doing sessions might be looking slower to some of you, but do not worry, because what we are doing right now is establishing the base so that everybody is comfortable. All right. So that in case there is some doubt left with someone, it will not be clear. They will not be learning anymore. So it's important to clear that base. All right. So that's why I'm taking a little bit more time. It's okay. We can have more classes, no worries. But more important part is that we should understand what we are doing. All right? Good. Thank you, Karthik. And yeah, I'm also learning a lot from these sessions. Okay, great. All right. Lloyd is saying that yes, Lloyd, we will discuss the same thing in Python. Trust me, you will be completely comfortable even if you do not know Java. All right, no worries. All right, no worries. You will be completely comfortable even if we'll consider shell. I think you know you are comfortable with shell. All right, and I'll also show you a couple of examples in Python. And for that matter, the first MapReduce programming which I did, the recommender, I wrote it in Python. All right, great. Have a good day, and thank you very much. And happy Teachers Day to everyone. Bye bye. Good night.